which make a big part of the industry of the future. Now, I would like to invite Assistant Professor Dr. Elif Sürer, Head of the Modeling and Simulation Department, to present Dr. Günter Wallner to deliver his speech.
Thank you so much, Kerem. It is great to be here. Welcome, Günter. Thank you so much for accepting our invitation.
Thank you.
Günter has actually arrived to our institute in 2020 as well, just before the pandemic. So we are looking forward to having the physical meetings soon. Let me introduce Günter to you. Günter Wallner is professor for game computing at the Johannes Kepler University Linz and holds positions at the Eindhoven University of Technology and Ontario Tech University. His research interests lie at the intersection of games user research, data analytics, and information visualization. His work particularly centers on understanding player behavior in games and on researching methods to explore and communicate the collected data to derive actionable insights for game design and development. As part of this, he is working on data visualizations to support the analysis of increasingly large-scale player behavioral datasets used in game analytics. His work has been published in international journals and conference proceedings, such as Kai Play, FDG, Computers and Graphics, and Entertainment Computing. He is editor of the data analytics applications in gaming and entertainment. Today, Günter Wallner is going to present us his talk, Empowering Players Through Data. The stage is yours, Günter. Thank you.
Thank you very much. I will share my screen. Does that work?
Yeah, it's great. Thank you.
Okay. So many thanks for the introduction. And many thanks for the invitation to give a talk today at the 25th anniversary celebrations. And today I would like to talk a little bit about data, specifically how data can be used to empower players. I also prepared this slide to introduce myself, but I think Elif now already covered most of it. So these are just a couple of examples of visualizations we did over the last years. So I will skip that now and just start with the presentation right away. And when Elif invited me to give a talk at this 25th anniversary, I was wondering what was actually happening 25 years ago in gaming. And it showed that, like, in the mid-90s, were actually a pretty exciting time and paving early ground for the interest in data from players that we see today. And this was the first time when Doom and other 3D shooters were getting popular to do a focus on multiplayer gameplay. And internet-based gaming was, of course, just like at the beginning at that time, but these games allowed to compete against each other through network play. And LAN parties have become very popular in the second half of the 90s to allow players to compete against each other. And over time, this evolved into a large business, which we now know as esports. And with games becoming more and more competitive and prize money being paid, players started to increasingly get interested in data about their gameplay to reflect upon and improve their skills. And companies have started to provide more and more data to the community to allow players to access their data, to compare them against each other, and allow them to actually build tools, for instance, for training purposes. And this talk is actually about how we can empower players by providing them with the data which gets collected from them. So what I would like to show today is a couple of use cases. Of course, it's not an exhaustive list, but just a couple of ways of how data can be used to empower players. And I would like to show solutions which range from the digital to the physical world. And I would like to start with using data for training purposes, as this is likely the most popular application for players currently. And indeed, in a study we conducted where we basically asked players of different genres why they actually watch replays or view post-play visualizations. And many of them mentioned reasons related to gaming, to learning to game and getting better at the game. For instance, players wanted to have a better understanding of situations, how they can improve efficiency, and how they can generally learn from their own gameplay, or of those from others. And in the following, I would like to show two examples of using data for these purposes. And in the first example, I will use Word of Tanks as a use case. So for those who don't know the game, it's basically a massively multiplayer online game in which two teams compete against each other for certain objectives. And each player is controlling a single tank in the game. And once the tank gets destroyed, the player is actually out of the game. And for that research, we have chosen World of Tanks for several reasons. Also, for one, because it captures the necessary data, which is necessary to reconstruct the match. And this in turn has also resulted in an active player community interested in data and in building tools for analyzing and visualizing this data. And we could utilize those players in our study. So those are a couple of visualizations we created. The first visualization is basically the common visualization of how those replays are visualized on websites. And it's basically two visualizations with each map showing the match from the viewpoint of one team. And the second one, which is below, combines the two views into one single map, and additionally shows the lines of fire between the tanks. Those are those small blue and red arrows you can see in the cropped out part. And the third visualization, which is here on the right, is basically an aggregated visualization. So it aggregates the individual movement data rather strongly. And so we evaluated those basically with players, and it showed that all of those were equally informative and suitable for analyzing gameplay. And this visualization, which was basically focusing on the individual movement, was especially lauded for its accurateness. And the aggregated one, especially for being clear, readable, and also aesthetically pleasing. But at the same time, I also need to point out that basically none of those visualizations could completely satisfy all players. So this basically shows that players are quite a heterogeneous group of individuals with contradictory demands, expectations, and preferences. And further research made us look into how those visualizations can be dynamically adapted to these demands. So here's another one, so-called Hex Spin Maps. So one of the most frequent tasks, if we are talking about gameplay, is to basically observe how certain metrics, how certain variables vary across a game map. And this is also reflected in the popularity of heat maps. so which are quite everywhere. And one of the drawbacks of those heat maps is that they usually focus on one variable. And this makes it quite difficult to compare multiple variables against each other and also across the map. And in this work, we addressed this issue by using maps based on hexagonal binning combined with visual glyphs to encode multivariate data. And the maps on this slide use real data from the real-time strategy game StarCraft, and it shows different information such as the number of destroyed units, team information, or the direction of attacks. And they also show a different amount of variables. So how are those maps basically created? So those small glyphs you can see are a variant of the so-called Vermin dot. And it's basically composed of two circles. So we have the outer circle that indicates the spatial area to which the data belongs to, and an inner circle which shows the actual data within this area. And by altering those visual attributes, such as the size and the color of the inner circle, multiple data values can be encoded. And in addition, we have those small arrows, which are basically direction indicators, which show directional information, which can also be very interesting for games. So basically, those glyphs have the advantage that they are quite simple, which makes them also readable when they become smaller. So if you have quite many of those on a map, they still remain readable. And the main map itself is subdivided into those regular hexagons used for binning the data, basically. And then a glyph is basically placed within each of those. And this glyph represents the data, that as explained a moment ago. And then we basically remove the hexagonal grid so that only the circles remain. And this has now several advantages, because with hexagonal binning, it creates areas of equal size, which now makes it easy to make comparisons between areas. And it also makes data captured at different time points comparable, as the subdivision is basically not affected by the actual distribution of the data. So again, we evaluated it. So we basically had a survey with around 200 players. And this survey showed that the participants basically appreciated the display of multiple variables. So it confirmed the value for analyzing gameplay. And those maps even remained readable with 3 and 4 variables. And we also checked if people interpret the data correctly, and the correctness achieved with the maps in terms of like estimating and comparing values was generally good, but sometimes reduced by the visual encoding itself. So one important takeaway message here is that the visual encoding needs to be chosen with care, as it can impact the performance of how players read those visualizations. So to wrap up the part of using data for training, here are some general recommendations for creating post-play visualizations. And we inferred it from another study. So first of all, one needs to carefully choose the data which is included, because not all information is equally important, and the relevance of the information can also differ based on the genre. It's also important to select an appropriate representation for the data, which is of course influenced by the data itself and the task which should be supported. Post-play visualizations are also not restricted to the information which is visible during play, so we can take advantage of that and include data which is otherwise inaccessible. And related to that, it's important to keep in mind that a certain information becomes also more or less relevant after playing. And lastly, players showed high interest in visualizations of high-level concepts that go beyond showing individual low-level data, and which instead require the integration of different types of data. So with those, I would like to move on to another use case, namely how we can use data to explain rules. And many games have quite different or difficult rules, like Dungeons of Dragons, for instance. And we thought that it might be quite useful to basically come up with a visualization which basically explains those rules to players. And here I would like to show you a video which the students have prepared, and which really nicely shows the concept behind that idea. Let me quickly try to start that.
Hi, I'm Daisy O'Neill, and I'll be presenting our paper, True Sight Battle Grid, Enhancing the Game Experience.
Günter, we are not seeing the video. We still do see the slides.
Do
you hear the sound?
We do hear the sound, but we don't see the video.
Data visualization is often
no, it's okay.
to provide feedback to players. However, little research has investigated its potential in hybrid physical-digital tabletop games or for tabletop role-playing games. Building upon the benefits of tangible interfaces, we introduce and report on the design of the True Sight Battle Grid, a modular, tangible battle grid for the role-playing game Dungeons & Dragons. Through visualizing gameplay possibilities with lights, we aim to provide players with information about the fantasy world without being distracting. In the popular tabletop role-playing game, Dungeons & Dragons, players assume the role of a character while the Dungeon Master, or DM, leads them through a story set in a complex fantasy world in order to complete objectives. Players commonly use tabletop maps, or so-called battle grids, to visualize and keep track of what's happening in the game world. Traditionally, these maps range from being simple drawings on grid paper to lovingly handcrafted terrain models. The maps help to collaboratively create and visualize the world, both before and during the game. Through conducting in-depth interviews, we found that tabletop role-playing games often involve lengthy discussions to resolve whether an action is or is not possible in combat. And this in particular can break the flow of the game. To combat this, we built a modular grid with lights that can be controlled by the DM, who sets up the map and loads the player's unique character data beforehand. The four main visualization possibilities of the grid are movement range, spell shapes, attack range, and line of sight. This helps players to see quickly and easily which actions are possible. The lights were also used to visualize the type of terrain, such as water or forest, dynamically light up areas of the map as players discover them, indicate whose turn it was, reveal treasure locations, display character conditions, and to distinguish between similar-looking enemies. Participants reported that the tool reduced interruptions during the game, usually caused by recalling rules or character ranges and making calculations. We also found that the tool makes it possible for both experienced and beginner players to quickly understand what is going on in the game. Our preliminary study indicated that visualizing gameplay possibilities with lights on a tangible battle grid helps role players to quickly understand and communicate gameplay data, as well as foster imagination and create new ways of storytelling compared to the traditional battle grid. Thank you very much, and please feel free to contact us if you have any questions.
So this was just another example on how we can use data. So basically to help players which are new to a game to learn the rules. So I will quickly move for a couple of other use cases now. And the next one is like how we can use data to improve the well-being of players. And here I would like to show another work which we did and which we called Have a Break. And the motivation behind this work was that many players basically spent long times in front of a screen, in front of their gaming devices. And this can have a detrimental effect on the mental and also the physical well-being. And to encourage players to take a break from time to time, we have designed this ambient tool that reminds players to pause gaming through pulsating lights. So how does it work? So we have the device, which is basically connected to a PC. And the PC is also connected to certain sensors. Specifically, we used a galvanic skin response sensor and heart rate data to basically measure the physiological data from the player. And the design of the device was basically guided by the objective to raise awareness, while at the same time avoiding to be too disruptive to the gaming experience. So we don't want to pull the attention from the player away from the game actually. And on the other hand, it should be able to place it freely on a desk, such that it can be integrated in almost any gaming setup. So, and for the appearance of the tool, you may have noticed it already, we took a little bit of inspiration of how like gaming accessoires and gaming PCs are designed. And when we evaluated the tool with 6 participants, we could see that participants actually took more breaks when the tool was present. And as a side effect, participants also reported that the blue light, which we used, was also calming and pleasant for them while playing. And they reported that they perceived the tool as a kind reminder to take a break, and they generally did not feel distracted. However, one issue was that sometimes the suggested breaks were not followed and rather ignored because something exciting happened in the game. And this was because the device actually did not take into account the gaming context. So it didn't know what was actually happening in the game. So let's move on to another use case, namely how we can use data to convey emotions experienced during play. And this one was actually not so much for the players, but rather for the parents of players. And the motivation behind this work was that games can basically trigger a variety of emotional experiences. They can induce positive emotions, they can alleviate negative ones, and they may also serve as a positive coping mechanism, which, however, may also become maladaptive at some point. And it can also be used for mood management, for instance, by offering distraction and to reduce stress. So games can basically serve many purposes here. And this, of course, also holds true for adolescents, young adults, which often struggle to talk about their emotions with their parents. And parents, on the other hand, may often not be aware of the impact video games actually have on their child. And as such, we felt that communication can benefit from mediators that basically facilitate that connection, that communication between parents and child. And to help bridge that disconnect between the emotional richness experienced by the players while playing video games and for parents, we designed this tool, which we called Motis. And Motis basically works as follows. So through a webcam and a facial recognition library, the experienced emotions of children while playing a game are tracked and submitted to this tangible device. The device itself consists of a radial base, which is split into 6 sectors, which are reflecting the 6 basic emotions, such as happiness, sadness, and anger. And these emotions are ordered based on how long they were experienced while gaming. And around the device, you can see an LED ring, which basically encircles the device and lights up in different colors to distinguish between those 6 emotions. And the ball also lights up to give some indication that it can be moved around the circle. So I will show a quick video to illustrate how that works. So you pick up the ball, and now you can move it around. And inside the ball is basically a magnet, and while you move around the circle, the device exerts forces on it, and it basically gives some kind of feedback, and the user feels basically how strongly a certain emotion was experienced. And then when you place the ball again in the middle, the device shows like a summary of the emotions. So in that case, it lights up green. So it was like mostly positive emotions which were felt during play. Again, we did like an evaluation. In that case, we did interviews. So we actually visited parents and child in their homes and brought the device to them. And the interviews basically showed that the device helped to contribute to a positive feeling of awareness. And the results suggest that this happens first and foremost due to the consciousness Motis creates. For instance, one participant stated that Motis made me think about the emotional state of my child, which would normally not pass my mind that often. Oops, sorry. And another one said that when there is no device, you are actually unaware about the fact that there are these many different emotions that are going on while playing. So it also helped to raise consciousness about those issues in the first place. And the increase in awareness was, according to the participants, also supported by the design. And there was a strong consensus that it was very important that the device was tangible, because that heightened the feeling of awareness. So participants, for instance, made remarks that the tangibility influenced my feeling of awareness in a positive way, because it's not only the visual aspect that makes you aware, it's also associated to the magnetic forces of the device. Or another one, Motis made me aware since I really needed to interact with it and experience it. The tangibleness supports that, since you really need to search for the emotions instead of just like seeing it on a screen, for instance. So like the tangible device forced basically the users to engage more deeply in the data, because we had to engage with it and not just view it on a screen. And I think with that, I'm also mostly, the time is mostly up. So I would just quickly recap that in that presentation, I basically just showed a couple of examples of how we can use data to empower players, like for training, but it's not just training, it's also to improve well-being, to help them understand play, and also to convey emotions. And I think like the basic message I wanted to convey is that there are so many ways that data can empower players. So it's important to think outside the box and basically see how we can use that data for the benefit of everyone. Thank you very much. And
our results indicate that the display of multiple variables at once.
Thank you very much.
Thank you very much, Günter. It was a very interesting presentation. I will have a couple of questions to ask you. So all those tangible devices that you had designed, they were mainly for the awareness. Are you planning to embed them as a feedback mechanism and also changing the game as well? Are you planning to have like use those data as input as well to update the game itself?
Yeah, so I mean, those were mostly envisioned as output devices, as you said. We did not so much look into designing input devices like controllers. But what we did recently is that we basically looked, so those were also rather like post-play visualizations. So that it presented the data after the fact. And we are also like looking into ways of how we can use those tangible devices during play, like the battle grid I have shown. So we are doing a little bit more work in that direction now, to basically present more live feedback while they are playing, to help them understand the gameplay a little bit better.
Because I mean, from awareness to action would be very interesting as well. As a child, I can feel, I can be aware of my emotions. Then how I am going to represent them, and how the game is going to adapt to my feelings. That will be also an interesting loop itself. I think, I mean, it's very exciting that there are lots of things to do, I think.
Yeah, thank you.
And the other one is that, I mean, you focused mainly on empowering the players by giving them more data and helping them and so on. From your observations and also like the end of the results of the questionnaires, are there any lessons to empower, or at least for the betterment of the designers as well? I mean, are there any lessons that you have noticed the way the players are responding to those cues?
I mean, I think I presented some when I talked about the training. So I think like one of the main things to have to be aware of is that you do not distract the player. So, and I think that's quite a difficulty, because at the same time you want to convey something, so players need to look at something, but on the other hand you do not want them to distract from the actual play. And I think that's a thin line, because that you need to strike that balance, and that's quite difficult in some sense. And like it's really about presenting the right data at the right moment. So like, because like gaming is quite context dependent, and so at some point some data may be more or less relevant in another instance. So it's important to figure out basically when something is important and when it's not important. So those are always these are all like tricky questions, and which also like depend a little bit on the game, of course. And so I think like user studies are really important to gather those requirements before starting out to design something.
Thank you so much, Günter. I know that this has been a very busy week for you, and I would like to congratulate you for the KaiPlay 2021 as well. It was a great organization, and Günter was a co-chair in that conference. And I would like to thank you again for accepting our invitation in such a busy week. And thank you so much for this very interesting presentation.
Many thanks for the invitation. It was a real pleasure to talk today. Thank you, everyone.
Thank you. Bye.
Bye.